Hello friends, in our last video, we defined identity as the equation that is true for the values that variables take. And we also saw the proofs of these identities. Today, let's see how these identities will help us in solving the problems. So, here is the first one. In this problem, we have to expand the expression 1 by 3 multiplied by x minus 2y plus z by 2 whole square. So, which identity will be used to expand this expression? For that, let's observe this expression carefully. So, here we have 3 terms and the exponent of their sum is 2. So, 3 terms and the exponent is 2. Which identity will be used? The identity that we can think of is a plus b plus c whole squared equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Since there are 3 terms here and the exponent of the sum is also 2. But if you observe carefully, the expression 1 by 3 multiplied by x minus 2y plus z by 2 is not exactly in the form of a plus b plus c. So what should we do now? Let's rewrite it. That is, we will write 1 by 3 multiplied by x as x by 3 minus 2y as plus of minus 2y and z by 2 will be written as it is. So now the expression is x by 3 plus of minus 2y plus z by 2, which is of the form a plus b plus c, where a is equal to x by 3, b is equal to minus 2y and c is equal to z by 2. Now let's use the identity and expand this expression. So x by 3 plus of minus 2y plus z by 2 whole squared will be equal to x by 3 whole squared plus minus 2y whole squared plus z by 2 whole squared plus 2 multiplied by x by 3 multiplied by minus 2y plus 2 multiplied by minus 2y multiplied by z by 2 plus 2 multiplied by z by 2 multiplied by x by 3. So, if you further simplify this expression, we finally get the expansion of 1 by 3 multiplied by x minus 2y plus z by 2 whole squared as x squared by 9 plus 4y squared plus z squared by 4 minus 4xy by 3 minus 2yz plus zx by 3. You understood this problem, right? Now let's move on to the next problem. In our next problem, we have to factorize this expression. So let's do it. I know it's a very lengthy expression. So tell me which identity can help us factorize this expression. Again, you have to observe the terms carefully. In this expression, we have 3 terms in which variables are raised to a power of 2 and another 3 terms in which 2 variables are multiplied to each other. Think for a while. In which identity do we get terms following the same pattern? Yes, the identity is again a plus b plus c whole squared equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2c. Here, in this expression, there are 3 terms in which the variables are raised to a power of 2 and the another 3 terms in which 2 variables are multiplied to each other. Again, if you observe carefully, the terms of this expression do not exactly fit with the terms of the identity. So, what should we do now? Let's compare the expression with the identity and see what happens. By comparison, if we equate a squared to 3x squared, we get a equal to plus or minus x root 3. Similarly, b will be equal to plus or minus 2y and c will be equal to plus or minus z root 5. Now, out of all these values, which values do we have to consider for the values of a, b and c? To decide that, observe the next 3 terms carefully. That is, the terms 2ab, 2bc and 2c. In our expression, the equivalent term of 2ab is minus 4 root 3 multiplied by xy. So we have to choose the values of a and b in such a way that 2ab will be equal to minus 4 root 3 multiplied by xy. So if we choose a equal to x root 3, then y has to be minus 2y, then only 2ab will be equal to minus 4 root 3 multiplied by xy. On the other hand, if we choose a equal to minus x root 3, then y has to be equal to 2y, since 2ab is equal to minus 4 root 3 multiplied by xy. So here we got two possibilities of the values of a and b. Similarly, the equivalent term for 2bc is 4 root 5 multiplied by yz. Here we already have the values of b. If b is minus 2y, then the value of c has to be minus z root 5, since 2bc is equal to 4 root 5 multiplied by yz. If the value of b is 2y, then the value of c has to be z root 5. So again, two possibilities for the values of b and c. So here we got two sets of values of a, b and c. Now if we substitute the values of a and c, we will get 2ac equal to 2 root 15 multiplied by xz, which exactly fits with our term. So we got two sets of values of a, b and c. Finally, we converted our expression in the form of a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca with two different sets of values of a, b and c. And we know that this is equal to a plus b plus c whole square. So our expression will be equal to x root 3 minus 2y minus z root 5 whole square. And it will also be equal to minus x root 3 plus 2y plus z root 5 whole square. Friends, here you must be having a serious doubt. How can a single expression be equal to two expressions? It can be equal if and only if those two expressions are equal as well. Here, the expressions x root 3 minus 2y minus z root 5 whole squared is equal to minus x root 3 plus 2y plus z root 5 whole square. Since in this expression, if we take minus 1 common, we get minus 1 multiplied by minus x root 3 plus 2y plus z root 5 whole square. And by squaring, we get the same expression as this. So, both these expressions are equal. So, in this problem, we have factorized this expression as minus x root 3 plus 2y plus z root 5 multiplied by minus x root 3 plus 2y plus z root 5. So, this completes this problem. Now, let's move on to the next problem. In this problem, this time we have to factorize this new expression. Here, this expression involves a variable raised to a power of 3. This is the first observation. Now, the second and the most important observation is 343 is nothing but 7 cubed and 8 is nothing but 2 cubed. So we can rewrite this expression as 2p whole cubed minus 1 by 7 whole cubed minus 12p squared by 7 plus 6p by 49. Since this expression involves the cubes of two terms, the identity that can be used is either of a plus b whole cubed or a minus b whole cubed. If you observe carefully, our expression contains negative signs, which implies that the identity of a plus b whole cubed cannot be used, and the identity that can be used is a minus b whole cubed equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. Now, let's compare the expression with the identity. So here we have 2p whole cubed corresponding to a cubed and 1 by 7 whole cubed corresponding to b cubed. So if we suppose A equal to 2p and B equal to 1 by 7, we can clearly see that even the remaining terms of the expression follow the identity as well. From these values of A and B, 3a squared b will be equal to 3 multiplied by 2p whole squared multiplied by 1 by 7, which is nothing but 12p squared by 7. And 3ab squared will be equal to 3 multiplied by 2p multiplied by 1 by 7 whole squared, which is nothing but 6p by 49. So, we can clearly see that our expression is of the form a cubed minus 3a squared b plus 3ab squared minus b cubed, with the values of a and b being equal to 2p and 1 by 7 respectively. Now we know that the identity is nothing but a minus b whole cubed. So the expression 8p cubed minus 1 by 343 minus 12p squared by 7 plus 6p by 49 will be equal to 2p minus 1 by 7 whole cubed, which is nothing but 2p minus 1 by 7 multiplied to itself 3 times. The most important step that helped us in solving this problem is identifying 343 as 7 cubed. So, I suggest you to learn the cubes of at least first 10 natural numbers so that these sort of problems will be easy. So go and start learning the cubes of first 10 natural numbers and meet me in the next video. Till then, stay tuned.